Okay, so in working these problems, first of all, they made a mistake here. So what we want to do is we're actually creating a new function, g of x, right? Describe the change in terms. So if our old function is f of x, and they're asked to translate this 3 units down, then our new function is simply the old function minus 3. Okay? So here, if I have a horizontal stretch by a factor of 4, so my new function is simply equal to the old function evaluated at 1 over 4x. If I have a vertical compression by a factor of 1/4, my new function is simply taking the old function and multiplying it by 1/4. If I have a horizontal translation 5 units left, my new function is simply going to be the old function evaluated at x plus 5. Horizontal compression by a factor of 2/3. So here my new function is simply my old function evaluated at 1 over 2/3 x, which is the same as the old function being evaluated at 3/2 x. A reflection across the y-axis. So remember, on a reflection, if it's across the y-axis, my y stayed the same, my x's changed. So my new function is simply my old function evaluated at negative x. Okay? So, number 7, here I have my function is 2x, and I shift the graph vertically 2 units. So my new function is simply my old function evaluated, my old function, vertically 2 units. Let's say it didn't say up or down, let's go up. So it'll be plus 2. So this is going to simply be 2x plus 2. So g of x, in this case, is equal to 2x plus 2. Okay? Horizontal stretch by a factor of 3. So my new function is simply my old function evaluated by 1/3 x. So everywhere I see an x in this expression, I'm going to replace it with 1/3 x. So this is going to become 1/3 x minus 3. So g of x, in this case, is equal to 1/3 x minus 3. Here I have a function, vertical compression by a factor of 3/4. So my new function is simply taking the old function and multiplying that by 3/4. Alright, so I got 3/4 times x over 4, which is equal to 3x over 16. So g of x is equal to 3x over 16, or you could say it's 3/16 times x. Alright. So continuing on. If g of x be the indicated combination of f of x equal x, so they want, basically we're going to do 2 functions. So if my original function of f of x equals x, so I'm doing a horizontal stretch by a factor of 5. So g of x is the old function evaluated at 1/5 x. So everywhere that I see a x, I'm going to put 1/5 x, so that's 1/5 x. Alright, and then horizontal shift right 2 units. So my latest function is simply taking the other function and evaluating that at x minus 2. So everywhere I see an x, I'm going to put x minus 2. So my h of x then here is going to be 1/5 x minus 2, which is equal to 1/5 x minus 2/5. Alright, for number 11, here I've got a vertical shift down 3 units. So if f of x is equal to x, g of x is simply equal to the old function down 3. So which is x minus 3. So h of x is taking the g of x function now and a vertical compression. So by a factor of 1/8, so I'm timesing that by 1/8. So I have 1/8 times x minus 3, which is equal to 1/8 x minus 3/8. So my g of x in this case, or h of x, excuse me, my h of x is equal to 1/8 x minus 3/8. Okay? And then a reflection across the y-axis followed by a vertical shift up 4 units. So if f of x is equal to x, then g of x, which is, we're reflecting across the x-axis, or y-axis, excuse me. So remember, if I'm reflecting across the y-axis, so my x's are different, my y stayed the same. So that's going to be this function evaluated at negative x. So therefore g of x equals negative x, and then we're shifting that up 4 units. So my h of x is equal to my g of x plus 4. So h of x in this case is going to be negative x plus 4. And finally I get to 13. Alright, so Tia's earnings can be represented by this function, where x is the number of hours she works. So it looks like she's making $5 an hour, and she's already got $120 stashed away. If she works 3 additional hours, her earning is now this, x plus 3. What type of transformation can be applied to the graph of f to get the graph of g? Looking at this, what's changed is we have a new x plus 3. So we could say that graph has shifted horizontally 3 units to the left. And we're done.